Okay, we're good to go. All right, hey everyone, welcome on in. Happy Monday. Good to have you here. Today we're meeting with Markus Kohler, developer relations engineer. Hey Sergio, welcome on in. We've got Markus Kohler, who is should be on camera, although the camera was doing some matrixy things right before we were getting started here. We're getting things set up. We're going to show you how to build some AI agents, implement OpenClaw, and give OpenClaw superpowers by giving them access to everything. Hey, Mohammed, welcome on in. Good to see you. All right, Markus, are you good to go on your side over there? We're trying to get things set up here.
Yeah, all good. Yeah, hello everyone. Marcus, developer relations engineer. Yeah, and we're gonna be mainly focused on just A2A today, so agent to agent protocol, but also, how to put a network behind that protocol that allows agents to be discoverable and callable, from anywhere. So really interesting stuff and just going to supercharge our AI agents today. But yeah, ready to get started.
Sounds good.
Yeah, so I made like a couple assets, I'm not gonna lie, for this live stream. Let's see if I can open them up. Just to like kind of go over A2A, why it was created, why it's so powerful, why this is like why everyone's talking about, this type of protocol, but also just like this technology and how we kind of moved from like MCP to A2A architecture. So this is a simple diagram of like, just a simple travel agent. And before, what we used to do before Google invented A2A in 2025, I think it was. And what we used to do was just like put all this information within this like one agent, like a travel agent. And there would be these like massive agents that people would use, and it wasn't scalable. It was hard to maintain, prompt engineering to the max to make sure your agents work. So what Google decided to do was kind of make these like microservices of agents. So for example, you would have this like one overlooking travel agent that could call a flight agent, a hotel agent, an excursion agent. And these would be like very small agents that would be perfected by people. And this one travel agency could like overlook all of that. So exactly like how humans, today work. It's like, you have a whole company of people, each person doing their own part in that, establishment. So, really similar to that. And so, you know, this is essentially what A2A is. And we're going to get into kind of like the protocol and then how we can actually find these agents and not make them all ourselves. So going deeper into A2A, you kind of have the terminology that I found online. I know some of this can differ, but essentially you have a user and it prompts this client agent. Sometimes it could be called other things, but this is like the main overarching agent to A2A. And then that agent can call one or multiple remote agents that are just smaller, like, defined agents that kind of do like one very specific task and then bring that information back to the client agent. So when we define A2A, this is essentially what is happening. We have, a client agent and there's some authentication, that goes on. And then, so the client agent gets authenticated by the remote agent. Remote agent authorizes that client agent, and then the client agent can just like send tasks. The remote agent can request for more info. The client agent can return more info. And then we kind of get into like this, kind of like what we see with like OpenAI and all these things where you can like stream the response back token by token or send the whole response back. And when we send a response back in A2A protocol, it's known as something called an artifact. So an artifact is just a return response from a remote agent. And yeah, so this whole protocol is really cool because it's defined by a JSON file. So it's not like language specific. You're not tied into like kind of like any language. The remote agents are identifiable through like a JSON, which I can like kind of show you an example of here. Let's go into this JSON, for example. This is like, you know, what an identity of a remote agent would look like, right? Because you would have like an agent name, a display name, a description. You might have some like inputs that it can take. You kind of have like its outputs that it can give back. And then you have tags to make it like findable. So this is kind of what A2A protocol is. It's essentially just a JSON file that, you know, so it's not language specific. You're not tied down to like any language when you're using A2A protocol. You're just using a JSON file that, you know, defines some inputs, outputs. You have a name, a display name, and all those things. So yeah, A2A is really cool, but you know, a year old now. But that's just kind of like my brief description of how A2A protocol works. So hopefully all of that makes sense. Currently not looking at the YouTube chat, so I'm not being a very good streamer. But you know, Steve is a lot better than me at this.
Yeah, we got a lot of people coming in. They're saying hello, welcome on in, like and subscribe.
Fair
Yeah,
enough.
we're doing good. We're doing good. I'll
Awesome.
have some questions for you here in a bit. Keep on going.
Yeah. So we're here not only to talk about A2A, but also what can make A2A even more powerful is the network that you can put behind it. And the network that we are going to be using today and this is called Blocks.ai. And Blocks.ai essentially allows your agents to be discoverable, findable, callable, you know, from anywhere, but it uses that same A2A protocol. It's just a network that allows you to connect to another agent over that A2A, that same A2A protocol there. So I have, and what makes it so powerful with blocks is that an agent can just like call any other agent on the thing. So you get these really like recursive, it almost like enables recursiveness within this A2A protocol when you put a network behind it. An agent can call another agent, but then that agent can call the same agent. So this is like a use case of this. It's a really fancy use case, but imagine if you had like a research agent, did all this research, and then you're writing a report, and then you have an editor agent that can, you know, kind of suggest changes to that report. That can be recursive in the sense that it can go back to the writer agent, and that writer agent can rewrite the report that can send it back to the editor agent. And you can get these really like recursive A2A agents if you want to get really fancy. I know that probably sounds a little bit more like a nightmare to debug when A2A becomes recursive, but yeah, really cool use case. But essentially a little bit more on blocks. It essentially makes agents findable, callable. You can use it directly on the portal. And one of the superpowers of this application. Oh, and also let me just say preferences before. If you want to get there, it's literally just blocks.ai. Nothing fancy. But yeah, if you want to go here, and then you can enter the network, and then we can go to the network here and go to all agents, and we just can discover agents and use them on this website. A lot of these agents right now are even free, so you could just go in and use any which agent. So, you know, an image describer. You can use my own personal agent, which is PA_Markus, that we'll go over today, that I made in OpenClaw. But you can use it right on this portal, right? So you could just go make me an image of a robot or something, and you can just like send that task. And you know, this is the network that is I don't think the authentication worked there from the portal, but here, let's try image describer. I don't know, any random one is fine. This one actually is pretty cool. It takes like a LinkedIn account and gives you the tone of it, so you can send your own LinkedIn accounts in there. Um, but essentially, yeah, you can run these agents on the Blocks website, and they can return the results. So you get to try out all these agents on this Blocks website. But this is all using this A2A kind of protocol. So these agents can call other agents on the Blocks network. And with A2A, it doesn't really matter, you know, the main purpose of it was it doesn't really matter how the agent was actually coded. Like that was kind of taken removed from the picture. When you have this, you know, travel agent, it doesn't really care about how the flight agent was implemented. It only cares about, what outputs and inputs it gives. So that was like a really cool thing about A2A is that all these agents are kind of black boxed. And in the same way Blocks.ai kind of works, all these agents are black box. So, it kind of just, you give it an input, you can see the output here in this .md file that it gave me back. And it's going to give me the tone and theme of this LinkedIn profile, which is, really, really cool that we get to try all these agents out and just have like a dashboard to kind of discover them. It's kind of taking that idea and just like making it really visible to the user. But yeah, that's my brief description of Blocks AI. Feel free to go on here, try out some of the agents. It also has like actually one thing I forgot to mention. Sorry, the agent is not hosted with Blocks AI. So I know a lot of these these softwares nowadays will try and go and like host your own agent. This is just to discover agents. So when you go and publish an agent to Blocks AI or whatever, the agent stays where it is. So that could be a Raspberry Pi, that could be a computer, that could be a server. The agent just stays where it is. Blocks AI just makes that agent discoverable. It opens up a connection to your agent. So these agents aren't like hosted by Blocks AI in any sort of way. It's just connecting to wherever the agent kind of already was. And we'll kind of get into calling these agents, implementing them into like a web application, publishing agents, and all that good stuff. So yeah, definitely check these agents out. Really, really cool agents to try here.
All right. Hey, Marcus, we got a couple of questions. You ready?
Yeah.
Okay. So here we'll do a tech question and then more of a where you are in your career and the position at PubNub question. So the
Nice.
first question
Awesome.
here from Bunzupi
Mm.
says, kind of describe what your current role is. What team are you on? How do you work at PubNub today?
Yeah. So, um, I'm a developer advocate at PubNub. Uh, what I do at PubNub is, I know developer advocacy is kind of like one of those very like kind of niche roles where it's different from job to job. So, whatever I say for PubNub and Blocks AI and the products we are making, don't take my word like directly one to one of how it's going to work at another company. But essentially, everything from, teaching about the kind of being like a product expert in like a sense in the technology. So just advocating for AI agents or, in terms of PubNub real-time systems, attending conferences, giving presentations, doing stuff like this where we go live and we just talk to you guys about, the different technologies that PubNub uses or Blocks AI uses and just advocate for the technology itself of why people need to implement and get on board and kind of just be like an expert in the subject matter. And then other than that, definitely like, you could go more into business development a lot more with developer advocacy, which is just like, talking to partners and doing collaborations and, all that good stuff. So like partnering with other companies, making demos, tutorials, blogs. So yeah, a lot of different things I feel like developer advocacy definitely gets their hands on. But I feel like, it's like focused in the same sense where it's like one thing at a time, you know? But yeah, that's essentially what I do. I hope I explained that properly, but yeah, it's definitely a harder role to explain to people for sure.
Definitely. And yeah, so everyone who welcome on in, thank you for joining in. We're here with Markus Kohler, developer relations engineer here at PubNub, has been with PubNub for over 3 years now, is walking us through AI agents, A2A communication, Blocks.ai. And Marcus, we've got more questions for you. Here we go. This one's a tech one. If you're ready, we've got a question about how we can trust these agents because they're not my agents. They're someone else's agents, right?
Hmm.
So how do we trust them and what are ways that we can, gain trust or maybe host our own agents, anything like that? What is your recommendation there? This is from Derek.
Yeah, so yeah, definitely like one of the things I mentioned just for everyone else, like in the diagram earlier on, was with A to A, you need to have some authentication based security scheme. With Blocks AI, it definitely works a little different because it's built on the on the foundation of PubNub, which has its own security mechanism to give these agents like the security to be trusted through like a token. But agents can be trusted. I feel like in like you know a like multitude of ways, in the sense that like you could just do like a JWT token or anything that could like kind of like authenticate the agent. But I wouldn't go like too deep into it. I'm not like a professional or anything on like the security mechanisms of like A to A. But maybe Steven, you can comment more on that.
Yeah, from a connectivity perspective, eight blocks AI is going to give you the option to host your agents anywhere in any framework. This is really powerful because most enterprises have multiple teams and different agents have value that could be cross team. So when you're hosting your agents, you have the ability to give invite invite users directly into the platform. You'll say this user, this team has access to this agent, and that agent over there has access to this. So you can basically give control over what information you want to share where. Now, when it's someone else's agent and you're just going through the public network here, obviously it's not something you can trust as a secure code execution environment. Marcus is just showing us here how you can invite users here on the screen. So this is a way that you can invite your team or only specific users directly to access. So that's from a access credentials perspective, right? So you can do that. That works really nice, right? And buyer beware on any of the other agents that are in the public marketplace. They're there for you if maybe it's trusted information you can pass on to them to like generate an image or maybe do a little bit of work that doesn't include any PII. So those are really good use cases for that in that situation. All right. I know. Yeah. Everyone's like, hey, why isn't Steven talking so much? Like, what's going on here? Yeah, because we got Marcus here from PubNub who's giving us a walkthrough on AI agents, Blocks AI, and A to A communication. So agent to agent communication. All right. Let's see. So we've got a couple other questions. Let me see here where we want this. We can't decentralize AI. Its resources consume. We need 24 hours and 7 of powerful servers to run. Oh, well, that's right. Okay. So that's another thing. Marcus, you'd actually be pretty good at answering this. Some of the AI that's running behind these agents is expensive and requires GPUs and things like that. Maybe
Hmm.
consumer grade hardware. Do you have any thoughts, Marcus, on how someone would choose to deploy their agent, maybe on a local computer or maybe a server? Like, how do you kind of see that working in the real world?
Yeah, I think there is definitely like an aspect of like you doing it yourself, which is like AI is getting so expensive. Like the GPUs and the just the pricing of compute itself is definitely like increasing drastically day by day. But like I think the main thing is like, especially with like Blocks itself, is like other like using other people's agents, right? Like you don't have to like, code these agents or like yourself or host them yourself. Like they're definitely like findable, these smaller, microservices of agents that you can make use of, which does lower the cost like a little bit. For example, finding an agent on Blocks.ai, or finding some agent that's hosted on another platform. Like these agents are going to be a lot smaller and probably don't work as good as these massive parameter models like Fable 5 or Opus 4.8. And those things are very, very expensive. Um, but and then there has been like like a pretty, I forget what it's called. It was like a pretty, maybe chat knows about it, but there's like a pretty substantial local model that dropped, and it kind of ranked the same as like Opus 4.8. I forget the name if someone can remind me. I think it starts with a G, but it kind of ranked in terms of like Opus 4.8 the exact same. And I've actually been thinking myself to run that model locally just to like pay an electricity bill rather than like a subscription plan. Um, but yeah, like there's nothing really else I could say. I fully agree with you. AI is getting super expensive and also compute at the same time. But I feel like there's just like ways to save on like a little bit of cost here. If that's running a local model, if that's, even putting down the, down payment to buy your own GPU and everything like that would be good. But yeah,
Chat figured it out. It's GLM 5.2.
that
Derek
was it.
figured it out.
That was it. Yeah, I was thinking about just running that, connecting it to a llama or like, even my cursor, my, Claude code. I honestly think that would be a great way to just save on a little bit of cost. I haven't had the opportunity to go and do that yet, but that's one of the things I was actually looking forward to doing.
Nice. All right. Excellent. Excellent. So let's go to the next one. We've got another question here. Also, for those of you who are joining in, thank you for hanging out with us. That's us today. We've got Marcus from Developer Relations Engineering at PubNub. We're walking through AI agents, Blocks.ai. And Marcus, Sergio wants to know what your feeling is about Blocks AI being decentralized. We talked a little bit about that, just a little bit more, and you hit on that a little bit. Would you have any? Are you happy about this? Like, do you think this is good? I think you're saying this is a good thing, right?
Yeah, I personally think so. I think when you think about like edge devices in like use cases under that, like I feel like the decentralization actually adds a lot to these, AI agents. For example, if like I put an AI agent onto my camera, my Raspberry Pi, or other things like that, these are like edge networks that like, they don't have to be like communicating to a computer, then like, sending to, the network after that. They could just be solely on this like edge device, and they could be really, really small, and they could do something very specific. And it's black boxed at the end of the day. Like the main overarching agent doesn't need to know how that agent works. It just does something for, that over, the client agent that I mentioned at the beginning. And I think it's good. I think, we had a problem before with, another reason it's good is because we had a small problem before with context windows. And context windows would constantly overflow and forget, and we would try to summarize them. And I think A2A is a good way to kind of manage that context window, to do like a lot more by sending these tasks off to other agents, but also just in terms of like maintainability, testing these, microservices of agents. It becomes a lot easier when the agent is a lot smaller and just can communicate over a network to a client agent. So, in terms of those points, I think, the decentralization of agents is a lot better. Um, just for what you want to implement.
All right. Excellent. That's good. Also, thank you for Development Software AI for just subscribing. You're on the right. Your name perfectly matches the theme of today's topic. Like, so
I can show you
Mark,
guys a demo of what I'm talking about as well. I
let's
do have
do
a
it. Yeah,
demo to
let's get
go
into it.
through.
Yeah. Yeah. Also, hey, Torva, I saw you had some questions in there and a couple other questions here. We can get those in a second. We're going to do a quick demo here. Marcus is going to walk us through.
Yeah.
Go ahead.
Yeah, so this is essentially everything I've been talking about, the Blocks network, the A2A protocol, and like what that actually looks like when we start using it as like a front end application. Something that we can visualize. This demo, completely open source, by the way. It's on the Blocks network GitHub. So just go to this GitHub, and it's called OpenClaw Agent Blocks. And essentially this demo works, just to give it some more context for people that, you know, joined. Sorry, let me just find the image I had before here. Like, this demo works, one-to-one with, this simple diagram. So you have the user, and the user can send a prompt. The client agent in this case is OpenClaw. OpenClaw is a pretty good client agent. It can like think for itself, make its own decisions. It has, a network of skills files that it can work its way through to gain new access to new tools. So that's your client agent. And then your remote agents, you're going to have multiple of those, is everything that the OpenClaw agent can kind of do, right? So, this demo works, one-to-one with, that diagram. You guys go to it as well and try it out for yourself. But you can do multiple things. But let's start with the basics. Like, I could record my voice, for example, and that's going to go to audio to text agent on the Blocks.ai. I've categorized all the agents so we can use all of them on Blocks.ai through this one application. So I can record my voice. Allow this time. Can you make me an image of a robot? Oh, that was too short, I think. Yeah, sorry. I actually don't think it's using the right microphone. Can you make me an image of a robot? And we can send off that voice clip. It can get transcribed onto Blocks. So this is using an agent on Blocks to transcribe my voice. So I had nothing to do with this agent. Like, this, it's just an agent I'm using. I don't really care about how it's implemented and how it works. It works, right? So I can just transcribe my voice. The next agent it's using, it's creating an image, text to image on Blocks. And, again, don't really care how that agent is implemented. I don't have to maintain it. So I can just use that agent on Blocks, and it can do this task for me. And as long as I like the output, it really doesn't matter how these agents are working. So it made me an image of a robot. So it transcribed my voice. It made me an image of a robot. That's cool. It works. It can also understand images, so I can like send in some sort. I can send a picture of myself, let's say, and be like, describe this image. And it can understand these images using these different images. So this is an image to text agent, for example. But we can go one step further. Oh, sorry. Do we have questions or?
Oh yeah, keep going. We definitely have
I
questions.
saw a thumbs up, so I was just like,
there's lots of questions. I'm queuing them up at the bottom of the screen.
Okay, cool.
Yeah.
Yeah. So this is kind of everything that we talked about. I can, integrate that with these Blocks agents, with my calendar. So this is like a personal assistant I'm running. It's also on Blocks. It's not working right now from the dashboard. But it's working from this UI. But anyways, we have another one though. We have PA_Marcus, but let's say two personal assistants want to talk to each other. So we also have PA personal assistant _ Bob. And my agent, when we go back to authentication, this is what you asked me about before, but my agent is actually invited to Bob's agent. So me and Bob, both of our agents can communicate with each other. So I could say, find me a time where me and Bob are both available to meet tomorrow. And that might be queued, but it's going to go through and find out. It's going to ask Bob, hey, when are you free to, there was an invalid time zone, but the plan is still secured. The demo people are not in favor of me today, but yeah, but essentially the idea there is like these two assistants can go and communicate with one another over blocks because they're authenticated with each other. And I could show you actually an example of this just working before, but essentially, it goes through finding a mutual time where both can meet, and then you can just like book that suggested time, which is like a button that comes up here, which is just all UI, all that good stuff. But you can go to your Google calendar. I don't know if I'm on the right account. I made another account for this. So let me do this. I connected it to another Gmail, but let me show you guys.
Sounds good.
But essentially you could go to another calendar here and, I have a meeting with Bob tomorrow, right? So it's just like you can add these integrations on top of it. But, these two personal agents coordinated with one another to create this, meeting, right? For me and Bob. So yeah, that's just like one example. Now, it gets really cool when you start talking about different things because this is just like A2A. It will just hire the best agent off of blocks. You can do race conditions, so the first agent to respond. You can do compare conditions, so it's like you can compare the two outputs and see which one's better. And then you can just like you could even do like an option where you hire the best of all agents and you have an AI judge to pick the winner of all the agents. So there's really cool things you can do to A2A. It's not just my agent's calling another agent. My agent can call 3 of the same agents and then see which one gives me the better result. So like you can do really cool things with A2A protocol. But that's essentially the short. I'll leave it at that because I feel like we might have questions here. So bring it back to Stephen. Let him talk a little more. My mouth is also getting really dry.
This is good. This is great content. I appreciate all everything that you're walking through here, Marcus. This is great. So yeah, we do have a lot of questions. I've queued them up. I'm scrambling. We've got like easily 10 plus questions. So let's see. Let's go with gloomy traffic here. This one may be a bit tricky. So lock in, you guys. Think about this. A little tough one. Do you think decentralized agents will outperform a single large orchestrator? Or does the communication overhead eventually become the bottleneck? I've got some thoughts, Marcus. What are you thinking on your side?
I think it's true, I want to say. In the sense that we just have seen like, these open source, agents and these small little agents using a bunch of other ones just become so popular and that like people are actually using them. I think, the big models are very, very powerful, but you kind of have to compare pricing with those big models. Like they don't get good as long as like if people are not using those massive, subscription services. They learn off of, our input and what we like and don't like about these models. So I think, if subscription prices keep going and keep getting kind of like absurd in that case, I think people will strive away from using these larger language models, which would slow down development and actually speed up development more for like these smaller decentralized, models. And as long as you have like a really good orchestration layer, which, we're getting to with OpenClaw, with Hermes, with these orchestrators that can, really push the needle in terms of how we think about, using AI. I don't know. I think, eventually I think it could outperform it. What do you think, Steven?
Yeah. So going back to the question from Gloomy Traffic, decentralized agents outperform a single large orchestrator, and then the communication overhead actually becoming the bottleneck. In this case, the communication for inference and when you're working between agents is actually going to be the lightest weight part of this, because right now the heavy compute, specifically when an agent is doing a lot of work, will be GPU level, and that has quite a bit of latency compared to the actual communication latency. So we've got a long way to go before communication becomes a bottleneck on that side. Specifically, when it comes to, like, if you're talking about training, you're going to want to train locally, because the amount of bandwidth that you need to transmit the batches in order to saturate the GPU on the memory bus, you know, it needs to be like, what is it, 100 gigabit, and you get that level of performance when it's running on chip to chip. So that's kind of what I'm thinking from an architecture perspective. But good news, the inference, we've got plenty of time. We've got plenty of distributed compute. We don't have to worry about that specifically, I think, at this point. So we're good to go there. All right. So Ruchi, Marcus, we've got a question from Ruchi here. It says, Markus Kohler, if possible, guide 24/7 agent. Oh, right. Okay. So if we are running our agents locally on our laptops, do we have to keep our laptop on the whole time? That's the question. That's an easy one, I think. What do you think, Marcus?
Um, I would like, yeah, like you can set it up where you could run an agent and your laptop can be off. We've seen this, before. Like I could open up Codex right now, which runs an agent with my laptop off, and there is settings where you can set that up. But generally, yeah, like with if you're running it locally on your computer, unless you have like a setting where you could do that, running it with like your laptop off, then um and you can enable that. Yeah, you would need your laptop on, but to run it. But yeah, I would have to like figure out a way to do that with specifically like my running an instance for my terminal, but it is possible to run with your laptop off as well.
Nice. Yeah. So you can have multiple agents deployed and running in different locations with PubNub with Blocks AI. It allows you to set what the current number of running agents is. When it's distributing work, it does round robin automatically.
Hmm.
So you could have one running on your laptop, one running on Raspberry Pi, one running somewhere else, and if one of the you just have to reboot your laptop or something, that's actually perfectly fine, because the other agent is going to take those requests. So it's got a built-in orchestrator, you could say, sort of for load balancing, and it's all automatic, which is one of the great exciting parts. I like that a lot. Let's see. So we got a lot more questions here. Marcus, do you want to go on to another question, or do something else? What do you
Yeah,
think?
yeah. Well, kind of the only thing I have left is to walk through kind of like how Blocks is implemented, like how we could publish agents. But we could go to maybe do a couple more and then just I don't know if there's anything we can answer.
Yeah, all right. So we've got a message from Torva. It says, will there be a feature to have selected agents working in a network? Also, thank you for the gold coin. Hey, Seuss, I appreciate you. All right, let me read that. Let me reread that question. The- Uh, will there be a feature? Another GG over there from Jesus. Sorry about that, Marcus. We're getting donations right now. They're distracting me. Appreciate that, Jesus. Appreciate it. Will there be a feature to have a selected agent work in a network? So the way I translate that question is, will you be able to select which agents that you're going to orchestrate? Like, how would you sort of group together a series of agents, and how would that work? Kind of my thought was orchestration through OpenClaw, right? Where you can
Hmm.
say, I want to use these sets of agents, or it can just decide what agents to use. Do you have any thoughts on that, Marcus?
Yeah. So just to be like just to clarify, we talk about like the discoverability of an agent and to see like what other agents it's using. So for example, like if I was to go to the network, go through, let me see, network here, go to the agents and be able to see, what other agents, this Power Plans Explorer is kind of using. Is that on the right track of that question?
Yeah, yeah. Like, which agents would I want to grant access to, like, say, my OpenClaw or my Hermes, or, you know, because I only want to give it so many of them, or do I want to give it all of them? Like, I guess isolation, or just maybe I get to choose. I want to pick and choose.
Yeah, you could do either or. Like in my demo here, let's see, give me all blocks agents. Let's see how it works in that sense. But essentially, getting at my question is like, yeah, you can make a cataloger or whatever that searches agents up by tag. Again, finding them from, let me see if I can open this up. Finding them from that JSON file I found, and they can identify themselves with tags, and you can, you know, use all the agents on blocks all at the same time through OpenClaw. But you could also, just make specific agents reachable through your OpenClaw instance, depending on how you want to implement that. My repo that you could see, on here, it kind of just uses all of them. So you can just like categorize, all these agents, and then you could just like pick one to use in that sense. So you could still pick and choose in this one as well, but when you give it a generic prompt, it will try to find that agent on blocks, and it will kind of try to use all of them. But in my opinion, that can get a little messy doing that. Like, I feel like that's like a little buggy of like an implementation, to be honest, if you try to use all of them at the same time, because you haven't tested like how they work, what they output. You're really just going off of like, how they're identified on the network. So in my opinion, like I would definitely like pick and choose like which agents you want your OpenClaw instance to use. But just to, have this repo can kind of do that in a sense, to be honest. Like it tries to use all of them, but it is, it can get buggy doing that.
Nice. Okay, yeah, that makes sense. And let me see. I'm going to see if we get one more question in here, and then we can. Oh, also, if we get a chance before the end of the stream, we could do, because your camera's not on. And they don't, who's this Markus Kohler person?
Oh, can you
Is what
not
I'm
see it
seeing in
on
the
my?
chat.
Can you not see it on the YouTube or like?
Oh, I mean, I've got Zoom up here, so
Yeah.
I've
Oh, okay. My thing's not on Zoom. Let
yeah.
me see if I can. Oh, did I turn it off then? Whoa. Let me see if I
Like,
can turn
who
it
is
back
this?
on.
Who's talking?
I got you
Yeah.
guys. Don't worry. Don't stress. Turn it on. You see
Is it
me
gonna work?
now?
Hey, there's Markus. Oh, we can see you now. Hey, all right. We should have brought it up earlier.
Yeah. I thought you were talking about like, oh, I thought it was on this whole time. I'm not gonna lie.
Yeah. All right. So all good. So we got a question. Who's Markus Kohler? Markus Kohler is developer relations engineer here at PubNub. We're currently walking through Blocks.ai agent-to-agent communication, working with maybe OpenClaw or Hermes, and how to give them superpowers by plugging them into a large ecosystem of available agents so they can call upon them, make images, translate audio, do all sorts of things. And we're currently doing questions and answers right now. Markus, anything you want to say to chat?
Oh, I'm new to this, so like I don't know. I'll probably start. I kind of like the idea of like Twitch streaming though, so I'll probably get into it. Just for like coding kind of purposes here, and there, just for like AI agents. But what's good, everyone? Yeah, Markus Kohler. Nice to meet you all. Sure to ask lots of questions. We're going over A2A right now, protocol, and the blocks network and how that empowers A2A protocol. But yeah, nice to meet all you guys. Excited to be here. Steven's a real Twitch streamer here, though. Don't get it confused.
We're trying. We're doing our best. We're doing our best. Hey, Markus, they have a they need proof that you're not AI.
I don't know.
They said
What
throw
would
a peace
AI not
sign.
be able to do?
Like throw a peace sign, put like your hand in front of your face. There you go. All right.
The John Cena?
Yeah, there you go. Yeah, exactly. All right, Bonzupi, we got your answer. Hey, Erdem, good to see you. Welcome on in. All right. So, gloomy traffic thought that was funny. All right. Real-time agents sound so cool. Let's go. Yeah, top one percenter. That's exactly what we're talking about right now. So let's see if we got some other questions here. Some sort of way to change used model on the hosts. So the cost for both the user and the host would be cheaper. Okay. So Marcus, this is a question from Torva. When you're building a Blocks AI agent, how do you choose if you need to add intelligence like an LLM into the mix? How would you choose which one to use? And if you need to go cheaper, how would you do that? Do you have any thoughts on making that selection?
Like, it kind of depends on, the task at hand that you want to achieve. Generally, like for me, like I usually like using like the smallest model to save on cost. Again, like A2A is like about empowering these really small, micro agents that kind of do like one or two things. Um, and also just speed and speed is just like a lot better in that case too. So you could kind of kill two birds with one stone, make your AI agents faster, make them cheaper. But like, I don't know, like I know like about like this what is it called again? Like I use this like rating system a lot. I forget what deep there we go. Deep sweet rating AI. Something like that. And then I just like go here and I can benchmark all the AI models, right? So I could just look here, see what the cost is, see kind of like what the performance is. You get to know. But these are like kind of like for the main like, AI coding models. But this is just like one, like I just use like these rating things online that they have to kind of like, you can see how much they spent, how many output tokens to achieve the same task, how many steps it took. You could use these different rating systems online to figure that out. But it really does, like, this is obviously for like more of like a vibe coding sense in terms of this rating system that people use this for. But yeah, you kind of just trial and error it would be my only other suggestion in terms of that. But it really depends on the complexity of the task, I feel like. But yeah, this is a cool site. I use this a lot. You just get to see like, like you get to see that GPT 5.6 Soul, is so much cheaper apparently than Fable 5 to achieve the same thing. And at $5 it outperformed at X high and a high and then Fable 5 at high. So, this is like the next model that I probably want to try out to save on cost too. So just use different rating systems and trial and error. But yeah, depends on the level.
Nice. Excellent. And we've got more. So yeah, questions are throwing. We're probably not going to be able to get at everyone's question. Just to let you know, there are quite a few. I've got them queued up here at the bottom of my screen. And the next one is, uh, I suppose, a good one that I think a lot of people would be interested in is, which you maybe have answered a little bit earlier in the stream. What is exactly a developer relations engineer? Like what?
Exactly.
Yeah.
I don't know exactly what it does. It could be different, like what I said before, like which company you go to. But currently, what I do is kind of just like, an expert in like a subject matter. So at PubNub, that's like real time systems. At Blocks.ai, that's AI agents, and you got to talk to just like developers every day. Trying to make the product better. Blocks.ai the product, or PubNub the product. See kind of like how these are resonating within like the developer field, and talk to developers that are using these products. Other than that, you're writing blogs, tutorials, making demos, using the product every day. You are going maybe to conferences, doing presentations, doing live streams, different things like that. So it could be a lot like of different things that you're doing, but yeah, I like it nonetheless. So
Nice. Good to hear it. Good to hear it. Yeah, there's a lot of tasks. It's like a multi-purpose role. You've got a lot of things going all day, every day. So let's see here. Let's go to gloomy traffic question really quick. So gloomy traffic says, is AI more regulated? Wait, as AI is being more regulated by the government, um, may push us to decentralize, but would that limit the agent's power?
Um, yeah, I think again, like, decentralizing agents are definitely probably not as strong currently as some of these like bigger, models with like billions of like parameters and other things like that. But I think, you know, um I think, yeah, just like the decentralization of AI agents is just like ever developing. Um, with Hermes, OpenClaw, and all the things that you can do on those. Even with Blocks AI coming out, you could use any which, agent decentralized. Um, like I just think like, yeah, just like the open source community is gonna probably catch up with these, larger models. So I do think it will limit the power though, like currently and we've already seen it, right? Like with uh like Fable 5 releasing and getting shut down instantly. So I would say that, but I don't know an insane amount of, exactly what they're doing to regulate AI, but I'll definitely look into that.
Nice. Yeah, that's is a tough topic because um, who knows what's going to happen, and there's a lot of competition in the world with open source and different countries trying to subvert what these major AI studios, the research labs, um, creating competition. I think is really valuable. The government side of things is a little bit of overreaction. I know we've got, what do you call it? 2029 is the target year for AGI, the singularity. So, we got, wait, how many years do we have left now? Was that 2 to 3 years? So we're good for a while. It's time to relax. We don't have to worry quite yet. When it gets really scary, I suppose, is a couple years from now. So, are LLMs overrated? Are they? Yes. Right? I think so right now, right? They're overrated?
Yeah,
I
I
think
would I
so.
would agree.
I think they're overrated at this point, and they do a really good job. They
Yeah, they
they
do.
write code.
Yeah.
Yeah. Let's see here. All right. There was a good question that I saw here that I wanted to get back into. I'm trying to see if I can find it here. The decentralized. We talked about that. Let's see. One large model. Do they speak binary? Yes. That's technically the answer. Let's see. All right. So let's see. Torva's got something over here. Uh, yes, but could you, for example, have one agent for a multitude of models? Oh, slightly tweak each other so that way it works with the same.
I thought that was the question originally too
Yeah.
when you first asked it. That actually is like an amazing on Blocks AI currently. I guess you could make a system, but we don't have like a specific feature for that on Blocks AI currently. But you could mess around and make some sort of architecture that it could probably achieve that, but not right now. But that is an amazing idea. I wrote that down. I was like, that's a good question. That would be really cool to make like different sets of models and other things like that for the same agent. Um, that's a really good idea.
Nice. Good to hear it. Good to hear it. All right, so we do have a few more questions here. I don't. Let's see. I know I've got a hard stop here at the bottom of the hour, which gives us about 20 minutes or so. However, do you have any other things that you wanted to share with the group, or we've got more questions? What do you think?
Um, yeah, maybe. Let me see if I can find like a. I just want to pull up like a quick demo of like how these things run and like how you actually get them on Blocks AI. Because we mentioned that Blocks AI is not hosting your agent. Like we're not a hosting platform. We're like a connection platform. We like connect all these agents together. So like, how is this agent like showing up here? Like, how is it showing active? So I just wanted to like kind of see if I could like differentiate that quickly.
All right.
Um,
Good.
yeah, I'll go through that. And then, so yeah, so if you want to get started, with using agents, calling them from like programmatically or like from a web app or anything like that, like you just go to the docs, quick start. Multiple ways to get started here. We have our own MCP, which you can use. You can just like add that, to your cursor or whatever, and it will know fully about blocks, be able to implement everything for you. There's even an easier way than the MCP though. There's this skills file here, and you can just copy this skills file, and then boom, now you're done. And you could put that into cursor as well, or Codex or Cloud Code or whatever, and make those things. But essentially how this works is, we have our own Blocks CLI. You can install that globally on your terminal, and now you can run Blocks commands. This is just checking the version. And essentially like how you get started is copy this command, and I'll show you exactly what it does here in a second. Let me close this folder so we don't give that information away. But yeah, so let's go into here, and we can actually, let's say we have like some code base here or whatever, and we want to put that agent onto blocks. What we're able to do is we're able to like just, let's say like, let's make a directory or something, cool agent. And we're able to like paste this command. If you want Python, I think it defaults to Python, but if you want like Node.js, you could just write Node. And then let me just write, you just run this blocks init command. But before that, actually, first you need to install the CLI, said that, but another really good command to run first, if my terminal ever initiates, is blocks login. So we can just run this command. It will do a Google authentication, and so everything can be pushed to the Blocks network. So we could just run this in our terminal after we install the CLI. And yeah, you'll need to be signed up on the Blocks website, and it will authenticate you through there. Anyways, that's how you kind of like authenticate Blocks on your terminal. But we can run this blocks init command. If I can run it right. Here, let me just get this. Sorry. I think something's happening. The code has not been so nice to me today. Let's see. There we go. So my agent Alice, I guess it's gonna be called. But yeah, so we did a node, right? And we just like named the agent. Oh, I see why it didn't work before. I just made an agent. I named the agent. Okay, this is one thing that wasn't like, the agent names have to be unique. So like that agent was already on blocks, and I didn't realize it. So I called it like cool agent or something, but like that name was taken. But like, yeah, like you could just actually no, I didn't even put a name in. I guess in this case they don't. Here they have to be unique. Sorry, let me backtrack for a second here. Yeah, so you can name this whatever you want. This just creates the folder, puts everything inside of it. Name that whatever you want. I just messed up and it didn't type for some reason. Because I'm bad at typing as well. But yeah, so we have this agent, and this is what Blocks kind of creates. It will have a Blocks API key. Don't worry about that yet. Since we ran the Blocks logging command, we can automatically make this through the terminal. And we get this handler function, which this is basically the core logic. Everything goes through this handler. Like this is essentially the handler that's going to be running and processing all the tasks. So when you go and use something from the Blocks website, this is the function that's going to get called. It sends a task, and it sends task context. So task context, you can report the status back of where the task is at, how far is it from being done. So like a UI can be like, hey, it's like this far from being, completed, and you can have like a timeline for your users at the end. And then it returns an artifact. And that artifact is just the same name. It's just a return value of what is being returned. And that agent is identifiable through this agent card.json. So you get to define like an agent name, a display name, a description. You get to define the inputs that are going into, the agent, and then you get to define its outputs. You get to define, its tags, so it's findable on the Blocks network. So yeah, it's just basically these two things that you have to. So here, like, essentially what you want to do is you want to call your agent, and then also don't forget, like, you could just use this. And then if you want to call another agent, I think CTX actually gives you the task client. So you can actually use this task client to go and call other agents on the network. And I'm going to show you exactly how that works as well. So going to some examples. Already had cool agent. Nice. All right, let's delete this because it's not part of it. And I'll just keep that for now. So we have like a time, but you can also actually define pipe, which is what you will need to do here if you want to stream the request back to your users. So it can go token by token and it gets streamed back as well. So stream object to stream the answer back there. But this is actually one thing I wanted to show you guys. This is using A2A because this agent can call other agents on the network. So we can go to the CTX. So it's passing in this task client that I talked about, and it can actually call with that agent another agent. So this is how we're calling agents from an agent itself in Blocks. So we have a couple different agents. We have a conversion agent, so it converts prices. I think this one's just like deterministic. Like it doesn't actually it just has like a table of stuff. It doesn't actually use like any API yet. I just like made it quickly like a deterministic one. And then you have a local expert. This one, I think it also is deterministic. And then, no, this one actually uses an LLM. I made it use an LLM just so if I could put in like Japan or Tokyo, I could like actually get like a real result. And then the weather agent, again, just like some deterministic thing that I made. But we can host all these on Blocks. So if you want to just test your agent out, let me get the exact command so I'm not lying to you guys. Yeah, so if you want to test it out, what we can do is you can cd into FX agent, for example, and you can just run Blocks register, right? And this will register your agent onto Blocks, but it'll be like free and private. So like, don't worry, it won't be like a public agent that anyone can use. And then we can actually use it on Blocks. We can run Blocks run with that. And then now it's waiting for a task to come in. So you can do that with all the other agents on Blocks. So let me see if I can open these side by side, actually. Sorry. I went to open up terminals. Let me show you guys what that looks like, though, just so you guys know that it's like working and stuff. If you do run these commands, I can show you what that looks like. This is my bad. This is my other Blocks account. I have two. Let me look.
Yeah, you got to
I know.
separate testing for testing out.
I know. There's so many at this point. I might have to sign out of this one. Let me do this quick, and then I will get back and show you guys what that looks like. But yeah, let me sign out of this account and sign into my other Blocks account where the agent actually is. I authenticated it with my other email, so here, just give me a second. Cool. Okay. So what does that look like now? Well, I just did this FX agent. I registered it. You can see it's private. It's invite only. And it shows active. So like the local expert, I haven't run the blocks run yet. So like it for example, if I go back to that cursor, like this one's running. But if I go like this and I CD into like weather agent, for example, and then I go blocks run, then like
Oops.
the
We got
weather.
people saying, good to have you here, Marcus.
Oh, thanks.
Say,
Yeah, so now like the weather agent's active just from that blocks run. So you can just see like which agents are currently running or inactive or active or whatever. Um, and yeah, I could just keep doing this until all my agents are running. I know I have so many agents that I've set up for this like example. I probably should have thought of it different. I'd like a simpler one. My bad, guys. And then I'll do one more. And then this is the last one. And then we can try these things out. So we can go CD into trip. So this is like the main one. This is our client agent that can talk to all the other agents on blocks. And all this stuff is getting sent through blocks. Like none of this is being done, you know, locally. Like all of this, like up another terminal. And we should be able to just use, you know, this system. So we can run, I have a trigger. So we should be able to just run it. And it's talking to the trip concierge over blocks. And it just sent in, you know, the city's Tokyo. My home currency is USD. My budget's $1,500, you know, and it can go and now plan out a trip. And it's talking to the AI local expert now, which is what we hosted over here. You see, and you can kind of see these things like working independently from one another. So all decentralized. And let me find the terminal I just opened, sorry. See the actual result at the end. And boom, nice. All the agents, you know, they just worked in their own little black box. We got the weather, you know, we got the currency conversion. You got like, you know, pack layers, and these answers came from all different agents. And then my agent at the end just kind of like summed it all up into this like nicely neat sentence. But guys, let's go like local expert or something. So I would CD into my agent, and I would CD into like one of the agents I want hosted, and I would just run blocks publish. And that's it. And then it's live, and anyone can use the agent. Once you run blocks publish, it won't be private anymore, and anyone can go and now use that agent on the blocks network. And it's discoverable, and you can identify it from the JSON that I showed. So FX agent, you can see exactly what it does. And then that description, right, is, you know, the same description here. But and then you can do pipe, you could do a single request, and now you could just like, you could send it tasks. I don't know if I stopped this agent from running. I don't think I did. Yeah, so you could still like, you could just send a task from like the blocks website. And yeah, that's kind of like the little demo I had for just like how to host an agent, how to call an agent, and how kind of like blocks is kind of pieced together with this A2A technology.
nice. Yeah, that was a great demo showing all those agents being pulled together like that. I think that sort of demonstrates one of the powers of blocks, being able to uh, leverage and call upon each other and getting different values. And
Yeah, I know it was pretty simple, but yeah. But you know, if you want to vibe code something more complex, just download that skills file or get the MCP that we have. Good.
nice. So we have about 8 minutes left here and quite a few questions. Maybe we can do like a lightning round of questions.
Yeah, sure.
All right, let's see. All right, so we'll start with Sergio. And some of these things are mostly on topic from blocks, and some of them are like more general.
Mm-hmm.
So, can there be multiple orchestrator agents working together? I mean, you kind of just proved that.
Yeah, yeah, multiple. Like if you wanted like a personal assistant or something, talk to someone else's personal assistant. Those would be like two orchestrators that branch off into a bunch of these other little agents, like fully possible to do with blocks. Yeah.
Nice. Let's see here. This one's more general. In the age of AI, will we see a lot more like web scraping and stealing of IP, or do you think we should really everyone should release their data or anything like that? Like any that's kind of like a hard, long-winded question, though. I was like, I don't know about that one. Do
I
you have
think
any
you might
thoughts?
have to repeat that. Sorry.
Yeah, it's kind of talking about, I guess, data ownership, and for my opinion, as from a business perspective, I would like everything about my business to be known. So it's kind of like free advertising, and I would say, whoa, wouldn't that be wonderful if these AI agents were able to know everything about my company? Like I would say that's the best. Now, there's another side to that, right? We could not want maybe we monetize our content, and if you're an author and you don't want the AI agents to steal that, although I still think it's free advertisement in any case,
Yeah, I would
either way.
agree. I actually think it's one of the things we try to achieve almost like so like we try to get like our, brands into, that so ChatGPT knows about it or like OpenAI or Claude. It's I feel like yeah, those are good things. I feel like it's like the new state of what SEO was, making things the you can send yeah, just you send a request after something is kind of like registered onto blocks. You register it through the um um sorry, the CLI but yeah, like you everything is done right now through like the SDK, but I think you can like if you go here actually, let me show you. You go here, you could do like, you know, you could just use like a web API, as well. But yeah, everything right now is done through the SDK, like within this demo.
Right. Mm. Yeah, that makes sense. So today there's a lot in the SDK that does orchestration between granting access to communicate, one-way channels, two-way channels. Is this a stream? Is it a broadcast? From a universal API perspective, from like a completions API, right? That is something that is a lot more simple. A to A just ends up being more complicated, and having an SDK take care of that is a lot nicer,
Hmm.
right? I would say it's a lot nicer. A universal API would be fantastic, though. Like, I would prefer that if we could have simple mode. All right, what do we got? 4 minutes left. Could the Blocks SDK include a task complexity evaluation? Ooh. Oh, wait.
That's cool.
Interesting. Torva, good question. When initializing an agent via blocks, can it dynamically route incoming consumer payloads to the most optimal model on cost and capability and constraints, overseeing the expenditure for consumer in terms of the host? Okay. So that's like a multi-layered question. Uh, do you have any thoughts on that, Marcus? I don't know.
Yeah, that would be pretty yeah complex. I'll let you go, then I'll see.
Okay, yeah.
I'll throw you in the under the bus here.
Right. Yeah. So the idea is, if we got a general purpose agent that can answer some questions, and you want to send it a complex or a simple question, you want an evaluator to say, is that question so deep that I need to send it to a large model to really think about it? Or can I send it to a smaller model, because it's a simple question? Basically, it's like a question complexity
Hmm.
evaluator.
Yeah.
So that is a really good feature that we haven't added. So that doesn't exist right now. We don't have that. However, you could add that into your agent.
Personally,
Right.
those pathways, like setting those up where it's like, oh, it goes to this model or this model, and then like the decision AI to like decide on what pathway it's going to take and what model it's going to end up at. I personally find those like actually really challenging to get all the edge cases covered because like anyone could input like any complexity. Like something could be like you can't go by like the length of the question because like that could be any complexity. So you really have to like it's really just like trial and error using these testing softwares that you can with AI to like cover all those edge cases. And I personally find those very difficult to kind of get right. Just because there's no nice way to go about testing all the edge cases, right?
Yeah, yeah, I'm with you on that. Yeah, that's uh, you would need to create a big corpus of training. Well, I mean, when I'm working with an agent, determinism is not there. There's no determinism.
Mm-hmm.
That's right. So you have to come up with as many possible scenarios and questions and prompts that can cover your outcomes and make sure that a goal is completed. That is, uh, and you have to run it multiple times, and sometimes it passes and sometimes it fails. So you have to be careful. Um, hey, what? Good to see you. All right, so we've got a couple minutes left here. Will we? This is from Loons. Do we have a rate limit, an RPM feature?
Yeah, you can rate limit your agent on blocks. Yeah, there is a feature for that. Let me see. Hopefully, I'm not wrong there. That's a
There
good
is.
question. There is a rate limit, right? Yeah, I thought I saw it like going through the docs. I haven't uh I've seen it before.
Yeah, I
It's
think it's
somewhere here.
the what do you call it?
Oh,
The
here.
concurrency. I think yeah, if you search for concurrency, it'll be like how many requests per maximum concurrent request each agent can handle. There's
There's this
yeah,
one here. Yeah,
there's some like soft limits that we have a general purpose, but yeah. Oh, see right there, it's rate limited, right there, easy.
yeah.
Hey, look at that. There's the answer. All right, 30 seconds left. One last question. Uh-oh. Let's see here. Will we compatible APIs using long-term bridge until native protocols mature? I'm trying to figure out. Let's see. So this one's an easy one from Loons again. Will we offer hosting for agents?
No,
Yeah,
sadly.
see, there we go. Yeah, easy. Yeah. All right. All right. I do want to answer this one last one from Gloomy Traffic. Gloomy Traffic's a longtime fan here as well on our channel. Do you see OpenAI compatible APIs as a long-term standard? Oh, wait. Or just bridge until the native protocols mature? So, okay. So this question, we're over time, but let's see if we can answer this question. OpenAI has a general standard on their API, and do we think that there's going to be a universal protocol for large language models? Because OpenAI kind of set the standard for those with the
Mm-hmm.
completion API, if you remember,
Mm-hmm.
and you just post your question and it comes back with an answer. Do we think there's going to be a real time evolution of that protocol? This is kind of like a general AI question for large language models.
Uh, I actually don't know. I actually don't know. Even if I have like I like a prediction on that actually. I would probably say so. Maybe, hopefully, like I would hope so. Like that these companies can work together to make like a universal, standard would be cool. But do I think it's gonna happen? Like probably not, to be honest.
Yeah. Yeah, I'm with you on that. We've got a pretty good. I think it was actually a pretty good level of invention already, and it has been copied by all the major studios, and it's implemented in all the agents today. It works really well. Can we optimize it further? Barely, right? We could barely optimize it further.
Mhm.
All right. Well, we got to wrap up here. Marcus, thank you so much for walking us through everything
Yeah,
here
yeah.
today on
Mhm.
AI agents and communication.
Yeah, thank you. Thank you for letting me meet your audience. That was awesome meeting you guys. Good questions. But yeah. Probably do this maybe again sometime. Maybe plan something out. But yeah, it was nice meeting all of you guys.
All right. Yeah. It says, thank you. Gloomy Traffic says, thank you, Marcus. You did well.
Thank you. Appreciate
You
it.
did well. All right, everyone. Thank you. Thank you for joining. Yeah, a lot of questions. We tried to get to most of them. Nice to meet you, Marcus from PubNub. Hey, Sergio, thank you. We'll be back. What are we doing next? We're gonna probably do random forest, machine learning next, probably a little bit later today. But yeah, that was Marcus from PubNub. Thank you again, everyone. Have a good rest of your day.
Yeah. See you guys. See you, Steven. Bye.
Bye, everybody.